We're asked what is the 10 to 90% rise time in picoseconds for an inverter in a 0.18 micrometer CMOS process if the total capacitance on the output of this inverter is 20 femtofarads. Now we're going to use the following kind of variables. Yours might be different, but we're going to go over the entire process to solve this. So the first thing that we're going to want to do is deal with this 10 to 90% rise time. And the simplest way that we can do this is going to be our step one. And in step one, we are essentially just going to have ln. We have our 100% out of 100%. So we'll have 100% minus our lower percentage divided by the 100% minus our higher percentage. And then it's just 10 and 90. And this is just going to give us an ln of 9, which is equal to 2.197 approximately using these variables. Now, what's step two? Step two is going to be what we have right here. So we're going to use our RP and this beta pi. This should be a beta pi. We're going to plug this into here to solve for this. So this is going to be equal to, we of course have our 1 on top. Our beta pi consists of our k prime p. So we're going to have 80 times 10 to the negative 6. That gets rid of our micro. We then have our WL, and since we are solving for this P for the rise time, we're going to use WLP. It's given to us as 33.6. And then lastly, we have our VDD minus V out. For our V out, it's just going to be the absolute value of our VTP. So we are essentially just going to have a 1.8 minus a 0.5, and that's going to give us 1.3. And we can plug this into a calculator and it's going to give us 286.17. So that's going to be the answer for our RP. Now let's go on to our step 3. In step 3, it's going to be pretty simple. We're just going to find the time for our P, and the time for our P is just going to be equal to our RP times the C out, and the C out is the total capacitance on our output. So we are going to take our 286.17 that we found, and we're going to multiply it by our 20 times 10 to the negative 15. And I'm not going to plug this in. I'm just going to multiply the 20 by this and carry this over. And if we do that, we are going to get 5,723.44 times 10 to the negative 15. So that's going to be our large answer here, and we're almost done. The last and final step is going to be our step 4. And in step 4, we're going to solve for the rise time in picoseconds for our inverter. So this is going to be equal to the time P multiplied by what we found in step 1, so the difference. So I'll just put part 1 right here. And if we multiply these two together, we are going to get approximately 1.25757 times 10 to the negative 11. If we want this in picoseconds, we're going to multiply this by 1 pico over 10 to the negative 12. And in doing this, we get an answer of 12.5757. So our answer for this problem using these variables are 12.5757. So that's how we would go about solving for this problem.